All right. So the last one, I guess, for this workshop is this machine learning. Machine learning is all the rage these days. It's really very simple. I read some good tutorials on machine learning. I realized this is what long ago I used to be a scientist. And you learn and the way you do science is you measure something like an electrical property or something, and you get some data, and then you make some mathematical model like that looks like a straight line or that looks like a parabola, and you fit the parameters. This is one level of science. When you're experimentally studying something that's very new and you don't really understand much about it at all, first you do taxonomy, where you just sort what you have into categories. And that's where we are in security with the attack framework. The attack framework just tries to organize all these security threats into some kind of categories so we can talk about them. That's the first step in science. If you get beyond that step, then you start measuring numerical things, and then you make graphs with just data on them, and then you just start fitting curves to it. And that's where you begin to discover laws, like the law of gravity and stuff, by observing patterns in the things you can measure. And so that's all this does. It just tries to fit curves to data. So you install some libraries, and then one common thing you use is this iris flower data set. This is a common beginning machine learning data set. You just have 150 measurements of flowers. There were 3 different kinds of irises, and you measured certain properties of these irises. And the point is, from those measurements, you should be able to sort the irises into categories. And your efficiency at doing that shows how good your machine learning is. So here's the data. So you import this stuff and it will print out the data. There's something called a sepal that has a length and width, and then there's a petal that has a length and a width. And that's your data. And then you know the right answer here, which class it is. So here's the measurements. And so you can make histograms. So here's the petal length of all the data, and the petal width, and the sepal length, and the sepal width. And as you can see, there appear to be at least 2 categories. So this is probably one type of iris, and this is apparently the other 2 types of iris that kind of overlap on this parameter, and they overlap on this parameter, but maybe not quite as much. So you try to find the best curve that would combine these measurements to most correctly separate it into the various categories. So you can make multivariate plots to see the correlation. And here you have a strong correlation between petal length and sepal length, and so on. So you can see if there are patterns in the data. And then you can try splitting the data into different categories and trying to make a mathematical model that will be a mathematical model that will figure out which category you're in from the data. And here it tries various machine learning models. There's the one that won was the support vector machines. This is the correlation coefficient, and perfect prediction would be a 1. The higher the number of this is, the more accurately you were able to sort the data. So this is the best one. So anyway, I tried to take some COVID data and figure this out. And I was able to import the data, but I wasn't able to make anything. What I was hoping to do here was the thing that later came out, where they would compare the red states and the blue states. And now that has become undeniable in the intervening time. The red states are all way at the top in COVID, and the blue states are all behind them. But when I wrote this several months ago, that wasn't so obvious. And I wondered if I could find that pattern with machine learning, but I didn't get that far. But anyway, you can play with this. Then there's another database called abalone. There's a bunch of these that are commonly used in machine learning. And again, there's different kinds of abalones, and you measure various parameters of the abalone and try to sort it. So anyway, this is how all machine learning is. It is trying to find some equation to describe the patterns it sees. And this is why, if you look at, there's a popular language processing machine learning out there now that will write text like tweets and advertisings and stuff. And you can see it doesn't know what it's saying. It just knows how to make a sentence that has approximately the right structure, because it's just practice sentence. And all it's done is made a sort of mathematical model of what a sentence should look like. So now it can create new sentences that sort of look right, but it doesn't actually make any sense. And if you try to read the paragraphs and have it add up to a story, it's not yet good enough to understand how a whole page should look. So that's where we are. The current state of machine learning is, I think we've moved from about the intelligence of an insect up to a very small mammal. We can do very simple tasks, but it's moving fast. And pretty soon it'll be able to do more complicated things. Anyway, But you can practice a little bit of machine learning with your Python, and I think it's very useful because you get to understand what machine learning is, and everybody is trying to sell you AI and machine learning products all over the place, and it might help you correctly evaluate how much good that's really going to do you. Anyway, I'll put this one up.